So on the warm-up, the front page is some more of the most missed problems on your quiz. So you may recognize them. Okay, so for the first one, we've got to just translate this sentence. So twice a sum starts off like that, twice a sum. And a sum of what? A number and 6 is equal to 3 times the number decreased by 2. So that's what the translation looks like. We're going to distribute here, and we get 2x plus 12. Now I need to get variables on the same side, so I'm going to subtract 3x on both sides. 2x minus 3x is a negative 1x. I'm going to bring down my 12, my equal sign, and my negative 2. I've got a two-step equation now. I'm going to subtract 12 on both sides. And I get negative 1x equals negative 14. And then last step is to divide both sides by negative 1. And I get x equals 14. So that was one of the most missed on the quiz as well. Question on that? Twice the sum has a parenthesis. That's a parenthesis phrase. Twice a sum. Good there? Okay. The next one is another translation of an inequality. I think the reason why this was the most missed is because some of us are forgetting that the less than is a turnaround phrase, so the 6 goes behind the subtraction symbol. So the 6 goes behind the subtraction symbol. What goes in front of the subtraction symbol is the product of 8 and a number, and product means multiply, so that's 8x. Is greater than or equal to is that symbol, and that could be another problem. We don't know our greater than or equal to symbol. 4 times the same number. So that's what it translates to. So the correct answer here was C. Okay. Another coin problem. John has 4 more nickels than dimes in his pocket for a total of $1.25. Which equation could be used to determine the number of dimes X in his pocket? So first thing I do is I look to see what the variable represents. It represents dimes, and the value of a dime is 0.10. So the 0.10 has to go with the X, number of dimes times the value of the dime. Okay, so can't be this one, because that's X plus 4, and can't be this one. So here we have number of dimes times the value of the dime, same here. And then this says the nickels, there's 4 more nickels than dimes. So that's X plus 4. So the correct answer is A. C is incorrect because that's not 4 more, that's 4 times. And it says 4 more nickels. Question on that? Did anybody get those right? Some of them? Okay. All right. Okay. Challenge problem. And if I think about it next week, maybe I'll give us a couple more of these. These really aren't that hard. The perimeter of a rectangle. So, y'all, the first thing I did was I just did this. That's one ugly rectangle, but there she is. Okay, it says the total perimeter is 106. Find the length and the width, and it says the length is an integer, and the width is 5 times the next consecutive integer. So we're talking about an integer and the next consecutive integer, x plus 1. So the length is an integer, so that'd be this. And then it says the width is 5 times the next consecutive integer. So there's the next consecutive integer, and there's 5 times that. And that's going to go over here as well. And all we need to know, folks, is perimeter is adding up all the sides. Okay, so we've got 5 parentheses x plus 1 added to 5 parentheses x plus 1 added to x, added to x. And it says that total is 106. So all I did was add up all the way around. So we distribute in both of these, and we get 5x plus 5. So I'm going to distribute both of those. And then bring everything else down. And now we're going to combine like terms. So I'm going to combine 5x, 5x, 1x, and 1x. So that gives me 12x when I combine all that. And then I'm going to combine the constants. Yep, 5 and 5 gives me 10. Equals 106. And now I have a two-step equation. So I'm going to subtract 10 on both sides. And I get 12x equals 96. And then I'm going to divide both sides by 12, and I get x equals 8. I'm just going to pause. There's people writing. Okay, so the length is 8, okay, because it says the length is an integer. So that answer would be 8. And the width is 5 times the next one. Well, 8 plus 1, the next one is 9, and I multiply by 5, and I get 45. So the width is 45. Just had to do a little thinking on that one. Okay? Okay, so on the front, and y'all, a lot of these rules we've already done, but I wanted you to have them in a notebook somewhere. Most of the rules that we did, I just told you to pull out a whiteboard and let you look at them. Now you've at least got them in your notes to refer to. So y'all, the product rule here says when I'm multiplying like bases, I add the powers. So that's what it would look like to add the powers. And we've already done this one. Okay, the power rule, that's where you got that little power sitting outside. Okay, in this one we multiply powers. So you would just write AB, which means A times B. So we're multiplying powers. And y'all, if you want to, you could write it here, add powers. And here we multiply the powers. Some of y'all know these and don't need to write that down, but okay. And then we've got power of a product. And that's where we actually distribute to everything in the parentheses, and we're still multiplying. So x would be raised to the a power, and y would be raised to the a power there. And we've done all of these. Okay? Okay. So now if you open that up, see they've got tons of problems here. See that? So I don't want to do all of them today or we're going to fall asleep. Okay. So product rule, this is the one where we're adding powers. So in this first box, what do we get? X to the what? We should know this one. X to the 7th. Okay, how about here? What do I do with coefficients? So I get 8, and what do I do with powers? Okay. 8, y to the 4th. Okay, let's do one more. This little guy here, even though we see parentheses, folks, there's no little power sitting out there. So we are still adding powers here. So x to the what? X to the 5th and y to the 5th. Okay? All right, the power rule is where we're multiplying powers. Okay? So let's do a couple of those. What do we get when we do this first one? X to the what? 12, because we're multiplying powers. Okay, how about this little guy here? Positive 8, because negative times a negative is a positive. Okay, we'll do one more. Y'all need to be very careful here. Do I raise 7 to the 3rd power? No. Why? That's right, it's not in the parenthesis. Okay, so all I'm doing is multiplying the powers on the y, and I get 18, and the coefficient is still 7. Okay? All right, the last one, where we're distributing that power to everything in the parenthesis. So let's do a couple of these. So somebody tell me what my answer is here. X to the y to the
6.
Yep, y to the 6. Okay, let's skip over here to this one. Y'all might need your calculator. What'd I tell you to do with negatives? Put them in a parenthesis all by themselves. If you put the negative 3 in parentheses all by itself and raise it to the 3rd power, you get negative 27. Negative because it's raised to an odd power, y'all. And then x to the 6. Okay, we'll do one more. Another negative. Remember, negatives need to go in parentheses all by themselves. And then we square it. What do we get? And it's a positive 25. Notice that's because it's an even power. And then a to the what? 6, b to the... Okay, easy enough. Okay? So what we'll do is come back and do some of these as the days go on to refresh our memory, okay? So you can set this one to the side. Let's go to these guys. Okay, now we are dividing like bases, so what are we supposed to do with the powers? Subtract. So we're going to write as a power a minus b because we're subtracting. And we've done this over the last few days, this one. Yesterday I gave you one of these where the parenthesis comes all the way down, so this power actually goes with both the numerator and the denominator. So this would be x raised to the a power divided by y raised to the a power. So we've done all of those. We only looked at this one time, but now here's the two kind of new ones, okay? The negative exponent or power rule. We do not want a negative exponent that's not considered simplified. Remember, y'all, simplified is kind of means easy on the eyes. I mean, it's easy to look at. And when we've got negative powers, that's not easy. That's kind of confusing. So basically the idea here is, y'all, it's called flip to rid. Flip to rid. So what does flip to rid mean? It means if the power is negative on top, move the base and the power to the bottom, and it's positive. If the power on the bottom is negative, you move the base and the power to the top, and it's now positive, the power. That's what flip to red means. So here we have a base of x raised to a negative power, and this is on top, so to speak, because there's no division bar. So in order to get the negative off the power, we move it to the bottom. And now the power's positive. And you guys experienced that a little bit. We looked at that a little bit with division yesterday and the day before. Okay, now here's an example where the power is negative on the bottom. In order to get that power to be positive, we're going to move it to the top. And now the power's positive. So this one's going to be a little new to you. Okay? Okay, this one, the zero exponent rule. If everybody would grab a calculator, and again, we're down to no calculator, so if you've got your own, let's pull it out so that we can share. I mean, we're really down calculators here.
I'll check my room, make sure nobody's looking.
Yeah, I mean, we're down to barely any. I want to demonstrate and don't have one. Okay? All right, folks, I want you to pick any number that you want. Doesn't matter. Pick a number and type it in. Any number. Pick a number and type it in. I don't care what it is. Okay, I'm going to pick a number. I'm just going to pick 50. You pick any number you want. Now I want you to hit that caret key. Hit that caret key, because that means we're going to raise it to a power. And then I want you to type in a 0. We're going to raise it to the power of 0. And if you press enter, everybody in this class got a 1 no matter what number you typed in. That's because anything raised to the 0 power is just 1. It's just 1. Now, y'all, here's the mistake that students make. Y'all, it's not x raised to the 1. It's just a 1. There is no more variable. Okay? There's no more variable. What I teach students to do is just cross through it. It's a 1. It's not x to the 1. It's just a 1. Okay? It's the number 1. Okay? Okay, so what I'm going to do is I'm going to do this backwards. When I flip over, I want to do these first and these second, because these are your new ones, okay? So let's flip over, and we're going to be at the bottom. We're going to be at the bottom. So the rule is anything to the 0 power is 1. So now take a look at these 3, because, y'all, even though that seems simple, it can still be confusing. Y'all notice here, this is a power to a power. But y'all remember we multiply powers. What is 0 times 5? 0. And anything to the 0 power is 1. So that whole thing becomes a 1. Okay, again, check out all this craziness here. We can raise 197 to the negative 7 power. We can raise x, we can multiply these powers, then we can multiply these powers, but lastly, what's getting ready to happen to every single power when we distribute? Well, every single power is going to turn into a 0, and then all that is a 1. So you're going to have 197 raised to the 0 power, you would have x raised to the 0 power, and you would have y raised to the 0 power. All of that's gone and becomes a 1. Okay, now this is where, it can get tricky. Okay, folks, the only thing here that's raised to the 0 power is the x. The 15 is not raised to the 0 power. The 15 is actually raised to a power of 1. There's no power on the 15, it's a power of 1. Okay? So you got to be careful that you don't just see a 0 and cancel everything out when some things may not cancel out. Okay? So only the x to the 0 power here cancels out. It's a 1. What is 1 times 15? That's why all I do is put a slash through it, folks. That's why I just put a slash through it. Because you're multiplying by 1. 15 times 1 is 15. We good? Okay. So let's go up to the negative exponents. Flip to red. So remember, if it's a negative power on the bottom, on the top, I move it to the bottom. If it's a negative power on the bottom, I move it to the top. The only mistake I see students make here is they forget to take the base with them. Like they take the number with them and forget to take the variable with them. You got to take the variable too, okay? So for instance, we have x to the negative 4. And this is in the numerator. In order to get the power to be positive, we have to move it to the denominator. And now it's a positive power. Okay? I love the way the author of this foldable did these, because they thought of every sticking point for a student to where they can make a mistake. Y'all, I watch people move negative coefficients around. Y'all, that's not what the rule says. The rule is for negative powers. Y'all, that 5, that negative 5, that is not a power. That's just a negative number. That's negative 5. We don't move that. We don't move that. The only thing we move is the variable that is raised to the negative power. That's the only thing we move. So the x to the negative 2 goes to the denominator, and it is now a positive 2. But y'all, the negative 5 stays put. That's nothing but a coefficient. That's nothing but a coefficient. So that would be negative 5 divided by x squared. Okay? Okay, here. Same thing applies. Y'all, you're only flipping the bases with negative powers. The 5 has a power of 1 on it. That's not negative. The x has a power of 2 on it. That's not negative. The 3 has a power of 1 on it. Y'all, all of these stay put. The only thing that gets flipped is the y. That is the only thing that gets flipped. So the 3 stays on top, the 5x squared stays on the bottom, and the only thing that moves is the y. It is flipped to the top, and now its power is a positive 3. So those are your newest 2 rules. Those are the last 2, by the way. Okay? And we'll work on these next week. Maybe a little bit tomorrow. Now, let's do the top real quick, just to, so we did a little bit of all of them. Okay? So, power of a quotient, remember, it belongs to the top and the bottom when that parenthesis comes all the way down. Okay, so somebody help me with what this is going to simplify to. What's it going to be on top? It's going to be x to the 3rd. Now, I want y'all to be careful. What's it going to be on the bottom? Oh, I heard it. It's not it. It's not 6. Y'all, it's 2 raised to the 3rd power. Okay, y'all, look. It's 2 raised to the 3rd power. Not 3 raised to the 2nd power. 3 raised to the 2nd power is 9. 2 raised to the 3rd power is 2 times 2 times 2. That's 8. Y'all so funny. Okay? All right, how about this one? What's on top? Y to the... Okay. What's on the bottom? What's in the denominator? X to the what? X to the 2nd. Okay? And last one. Y'all might need a calculator. This isn't 3 times 4. What is it? 3 raised to the 4th power.
81.
Okay, so we get 81 x to the 4th on top in the numerator. What do we get in the denominator?
256.
Yeah, 4 raised to the 4th is 256. Okay.
And y.
And y to the 20th power. Okay, last but not least, we've done these and they'll be on your scavenger hunt. When we're dividing like bases, we subtract powers. And remember, we also want them to stay positive. So that's where we're moving them to where the power's the biggest. So for this one, the power's biggest on top, so the x is going to stay on top. 10 minus 4 is, this is x to the 6th power. We divide coefficients. 12 divided by 3 is 4. We subtract powers. That's going to be x to the 5th. Okay, here, careful. This isn't 15 divided by 5. This is 5 divided by 15. 5 divided by 15 is 1/3. The 3 is on the bottom. And then x is on top to what power? What are we supposed to do with powers? Subtract. 6 minus 4 is 2. Okay? So now, a couple of things. We're going to work on some of these. You may choose to glue these or to not glue them. But it's going to take up 2 sheets of paper in your notebook. Okay? So I'll get some glue sticks out and let you glue these. It's going to take up two pieces of paper in your notebook because they're so big. Okay, so if you need a glue stick, you can come get one. I'll put them right here. Let's glue these in our notebooks.